In today's lesson, we are going to learn about the definite integrals. So what is the difference between definite integrals and indefinite integrals? Before this, we deal with indefinite integrals. For example, if we integrate a function f of x with respect to x, so we will get a certain function and we need to add with a certain constant c. C can be any constant. But when we deal with definite integral, there are things that we call as boundaries. For example, if we integrate the function of x from a to b with respect to x, the result should be f b minus f a. So in definite integrals, we do not have plus c. That's the difference between indefinite integral and definite integral. From a to b, these two is known as the boundaries. Okay. So the difference between indefinite and definite integral, indefinite does not have boundaries, but for definite integral have boundaries. Now we are going to have a look at the laws of definite integrals. There's a few laws. The first one, integration of f of x from a to b is written as integration from a to b of f of x with respect to x. Second, if we integrate f of x with respect to x, we get f of x plus with c. Then integration of fx with respect to x from a to b is just equals to fb minus fa. The third one, if we integrate from a to b of the function f of x with respect to x, if we integrate a certain constant multiply with function from a to b with respect to x, then the constant can be bring outside. So this is just equals to k integration of from a to b of f of x with respect to x such that k is a constant. Properties number 4. Integration from a to b of a function fx with respect to x is just equals to negative integration from b to a of the same function fx with respect to x. And the last one, integration of a to b of the function fx with respect to x plus with integration from b to c of a function f of x with respect to x is just equals to, if you notice, A to B, then B to C, as if we can cancel B and B. This will produce integration from A to C of the function with respect to x. So these are the important properties that you need to remember for definite integrals. Now let's have a look at the example. Example: find the integral of 3x minus 2 from x equals to 1 to x equals to 2. Means that we need to find the integration of function 3x minus 2 with respect to x from x equals to 1 until x equals to 2. So what we do here, we just integrate like usual. So if we integrate this function, we will get 3x squared over 2 minus with 2x plus c, but because we involve boundaries, we do not need to put plus c. Instead, we put bracket and write 1, 2. The next step would be top minus bottom. So we use the same function, we just substitute 3, so x as 2 squared divided by 2 minus with 2 times 2. So substitute the top, settle, minus with bottom. Means that the same function, 3, 1 squared over 2 minus with 2 times 1. And we solve this. So this will be, you just use your calculator. So we should get for the first part is equals to 2 minus with minus 1 over 2. So the final answer is 5 over 2 or 2.5. One more example. Evaluate integration from -1 until 2 of this function. So we have integration from -1 until 2 of 2x plus 1 multiply with 2x minus 1 with respect to x. In this case, we need to expand this first. So this is in the form of a plus b and a minus b. So when we expand, we should get a squared minus b squared. So in this case, if we expand, we should get this is just equals to integration from -1 until 2 of 2x squared minus 1 squared with respect to x, which is just equals to integration from -1 until 2 of 4x squared minus 1 with respect to x. Then we integrate like usual. So it becomes 4x to the power of 2 plus 1 over 2 plus 1 minus with integration of 1 is just x. Since we involve boundaries, we do not put plus c. Instead, we put bracket from -1 until 2 and continue. Becomes simplify the equation in the bracket, we will get 4x to the power of 3 over 3 minus x from -1 to 2, then substitute above minus bottom, we should get 4 to the power of 3 over 3 minus 2. So this is the top, minus with bottom, 4 times with -1 to the power of 3 over 3 minus with -1. So this, by calculator, you should get final answer is 9. Okay, the next example. Given integration from 3 to 6 of a function f of x dx equals to 4, find the value of a. Integration from 6 to 3 fx dx. Okay, take note from the properties. From the properties before, integration from a to b of a certain function with respect to x is just equals to negative integration from b to a of the same function with respect to x. So if you want to change the boundaries, you need to add negative. Okay, there. So in this case, since we are searching for integration from 6 to 3, this should be equals to integration from 3 to 6 of the same function with respect to x, but we need to put negative in front because we swap the position of the boundaries. So this is just equals to negative, since it's given that integration from 3 to 6 of fx dx is equals to 4. So the answer should be negative 4. Okay. For b, find the integration of this. And from the properties, we know that as if we can cancel 4 and 4. So we will produce integration from 3 to 6 of the function f of x dx. So given that integration from 3 to 6 of the same function is equals to 4, so the answer is just equals to 4, because this is just the same integration. Okay, now let's go to a slightly difficult question. Given that when we differentiate this function, when we differentiate x squared over x plus 3, we will get fx. Calculate this value here. Okay, how to answer this question? If we differentiate x squared over x plus 3, we will get f of x. It's given from here, which means that if we integrate f of x, with respect to x, we should get x squared over x plus 3 easily, because it's just the integration is just the reverse process of differentiation, vice versa. So in other words, from here we can conclude that integration of function f of x with respect to x will produce x squared over x plus 3. Now, the question wants us to find the value of integration from 0 until 2 of the function x plus f of x with respect to x. So, which means that we can actually separate the integration into two parts. Okay. if you want to separate it. If you don't want, then we'll do it straight. So in this case, integration of x is just equals to x to the power of 2 over 2 plus with integration f of x is this one. So x squared over x plus 3 and involves boundary from 2 to 0. So we just write 2 to 0. The next step is we just substitute the value in. So it becomes 2 to the power of 2 over 2 plus with 2 to the power of 2 over 2 plus 3 minus with 0 to the power of 2 over 2 plus with 0 to the power of 2 over 0 plus 3. So top, this is the top, minus with the bottom, this is the bottom. The final answer should be, you should get 2, 4 over 7. So it's just, let me see, by calculator you should get 18 over 7, which is just equals to 2, 4 over 7. So that is your final answer. Basically, we have done the definite integral. So you have the main idea, the brief idea of what is definite integral. In the next class, I will cover integration as summation of areas. Okay, that's it for now. Bye-bye.